right, so last class, we just did more practice with solving equations and inequalities. Thank you. So last class we just did more practice with equations and inequalities, and today we're going to do even more with inequalities. Thank you, kids. Okay, so last class we did more practice with the equations and inequalities. Today we're doing what are called compound inequalities. So there's more happening than just one single inequality. And again, this is just a review of what you did last year in pre-algebra. We're still doing some review. But I want to go ahead and just a real quick refresher. If we had, let's say, 2x minus 7 is less than or equal to negative 10x, we'll make that a positive 10x. Minus 4. Then we would solve this just like we did with the equations, where we'd want to get our x's on the left side and our everything else on the right side. So I'm going to go and subtract my 10x over. Now I would have negative 8x minus 7 is less than or equal to negative 4. And I would add my 7 on over and get negative 8x is less than or equal to positive 3. Now I have to divide by my negative 8. And what do we have to do when we divide by a negative? Let's switch the sign. Good, flip the sign around. So greater than or equal to negative 3/8. All right, and then this was our answer. We would graph that on a number line. This isn't a very nice number, it's a fraction. So let's just say that's your negative 3, it's probably right around here. Now, is this an open or a closed circle? Closed, because we have the or equal to. And then it's pointing to the right, so we would go to the right. So that's what we did for the last two classes, right? We just had a simple inequality like this, we solved it. What we're doing today are called compound inequalities. So compound inequalities joins two inequalities together. So either they'll be listed separately or they'll be listed all together. All right, so a compound inequality, this is what we're working with today, so I'll write this down in your notes. A compound inequality, compound is a set of two inequalities joined by the word and or the word or. So compound is you're taking two inequalities and putting them together. All right, so let's start off by talking about the or compound inequality. So an or compound inequality literally says or, right? So we have x is greater than or equal to 0 or x is less than negative 2. So there's two inequalities. We're saying it can be either one. All right, so when we have or, our arrows are going to be going in opposite directions, kind of like oars on a boat. So if you think about like canoeing, yeah, go back and that would be good. Thank you. So just like if you were canoeing or kayaking, when you are rowing, the oars go in opposite directions. Okay. All right. So or inequalities graph on the outside or in opposite directions. In the outside or in opposite directions. So again, it's like oars on a boat. They're going to go in opposite directions. So when I take a look at it, I do each one individually. X is greater than or equal to 0. So I'm going to go at 0. Is this an open or closed? It's a closed because it has the or equal to. Okay. Sorry, the smartboard has this weird point where it goes a little wonky. Let me try it. All right, there we go. And it is pointing to the right, so we will draw our arrow to the right. All right, and then we have Yeah, so we're now to the other. So right now I've only graphed x is greater than or equal to 0. So now let's go and graph x is less than less than negative 2. So I get negative 2. Is this an open or closed circle? Open, so I'm going to put an open circle at negative 2. And it's pointing to the left. So I point to the left. We can see they go in opposite directions, right? They go away from each other. All right, let's take a look at our next one. And I'm going to orient this one more time, and then I'm giving up on it. Let's see if we can make it work a little bit better for us. All right, so we have x that's less than 1 or x is greater than 7. We should expect them to go in opposite directions. So let's do each individual one. X is less than 1, so I go to 1. Is this open or closed? Open. And it's pointing to the left, so it should be pointing to the left as well. All right, everyone should be writing this down in their notes. Writing this down here, the notes. If you have to be here anyway, you might as well do something. And then we have x is greater than 7. Is this open or closed? Open. There's no or equal to, so it's still open. And it's pointing to the right, so we go to the right. Notice again how they're in opposite directions. Opposite directions. Okay. So we're going to have to solve inequalities with or in it, just like we solved inequalities before. So when we solve an or inequality, we're just going to do them separately, right? We have basically two inequalities. We're going to just do them individually. Right, so to solve an or inequality, solve each problem separately, then write in set builder notation and graph the number. All right, so this is just like we had before. All right, so I'm going to start off by solving this one on the left. I have a positive 19. What do I need to do to get rid of it? Subtract it away. Then minus 19. So negative x is less than or equal to 10 minus 19 gives me negative 9. Notice my negative is with the x. It stays with the x. We're going to rewrite that. Thank you for reading this time of year. Thank you. All right, I have negative 1 times x. How do I get rid of that negative 1? Multiply or divide by negative 1. We're currently multiplying by negative 1, so we want to divide by negative 1 on both sides. So I have x. What happens to my sign? Flip it around. And negative 9 divided by negative 1 gives us positive 9. Alright, so that's one of our solutions. Let's go and write the word or, because we know we're going to have another solution. And let's solve our other side. I have negative 15. How do I get rid of it? Positive 15. We're going to add 15 to both sides. So positive x. I still have less than. Negative 8 plus 15 gives me positive 7. All right, so I'm going to start listing down here. So our answers are x is greater than or equal to 9 or x is less than 7. So there's two chunks of our number line that it could be in. All right, now it says to write it in set builder notation. So let's go ahead and practice that. Remember set builder notation, we just draw a squiggle, x, vertical bar, and then we just list what we found for our solutions. X is less, sorry, whoa, it's really freaking out today. X is greater than or equal to 9, or x is less than 7. Now, it's usually best if we were to write it where we have the smaller number first. It doesn't really make too much of a difference, but normally it would be better to write this since my 7 is the smaller one. I would probably write that one first. On a test or quiz, Either way is okay with me. Okay. And then it says to graph it on the number line. So my 7 is an open circle. And it's pointing to the left. All right, and then I have 9. Is that open or closed? Closed. And it's pointing to the right. Again, they're in opposite directions. 4 opposite directions. All right, so we have questions on how to solve this. Okay, so let's take a look at our next one over here. All right, so same idea. We have some ors. But we have to deal with some fractions, but the exact same thing that we were doing the last 2 classes. We're just going to have to do it twice. So let's start off by solving the one on the left. Let's get rid of addition, subtraction first before we get rid of multiplication, division. So if I have positive 5 plus 5, what's the opposite? What's the opposite of plus 5? It's negative 5, subtract 5. And x over 2 is less than negative 3. And just the same thing we did last class. All right, now I'm currently dividing by 2. What's the opposite of dividing by 2? Multiply by 2. I'm going to multiply by 2. Two's canceled. Do I need to flip my sign here? No, it wasn't a negative. So negative 3 times 2 is negative. Oh, I flipped. I said not to flip, and then I did it. I'm sorry. If we do not flip it, we just multiply again. All right. And then same thing on the other side. Let's go and solve. Again, we're going to get rid of our negative 2 here. So we're going to add 2 to both sides. So negative x over 3 is less than or equal to negative 2. All right, I'm dividing by 3. How do I get rid of dividing by 3? Multiply by 3. So my 3's cancel. What we need to be careful with, remember a lot of us lose our negatives along the way. My negative is still with my x, so I still need to write that out. And it's negative 2 times 3 would be negative 6.
It's the same.
It's not quite the same. It's close. I still have to get rid of this negative here, don't I? So if I have negative 1 times x, I want to divide by negative 1 on both sides. This will cancel, and now we will flip our sign, and we get positive 6. All right, so when we go to write our answer in set builder notation, remember we still have 4. So we have 2 solutions. X vertical bar. So x such that, and we would write this one first because it's a smaller one. X is less than negative 6. Or x is greater than or equal to 6. You don't have to underline your or, but it's important. So again, we would just write it in that set builder notation. Right, questions as to how we do that set builder notation? All right, so let's take a look. We have negative 6. I'm going to go to negative 6. Is this open or closed? Open. How do I know that it's open? I keep asking this, but let's make sure we all remember. How do we know if it's open or closed? Yeah. So when we have the equal to sign, that's when it's a closed dot. Less than or equal to, greater than or equal to, or just equal to. If it doesn't have that or equal to, then it's an open dot. Here. There, so we have an open dot at negative 6. It's pointing to the left. I don't want these connected. And then I have a closed dot at positive 6. pointing to the right. Again, in opposite directions. If you have that they're going overlapping, then you probably messed something up. It's possible that we would have a problem like that, but we are trying to not give you a problem like that. Something you might get like an algebra too. So it should be in opposite directions. Okay, questions on this? All right, I want you guys to go and flip your paper over. We're going to come back to this. We'll go and flip your paper over. And take it back. Take your paper back over. Sorry, I thought there was a problem there, but there's not. Okay, so our ors, those are our easy ones. They go in opposite directions. Alright, so these are easy ones. They go in opposite directions. Now, our other kind is called the and inequality. Salty, are you with us? Stay focused. So when we have an and inequality, there's two ways we can write this. One of these days, we'll get there. And I'll have to stop guessing where the smartboard is. But in the meantime, I'll keep my patience. All right. The other type of compound inequality is an and inequality. There's two ways we can write this. It is way more common to have it like this, where it's written as one big inequality. It's not as common to see it like this with the and in between. It's much more common to see it here. We'll look at it both ways. So what we have here is it's saying x is between 2 and 5, right? X is in between 2 and 5. Here it's saying x is greater than or equal to 2 and x is less than or equal to 5. It's the same thing. X is this and this mean the same thing. They're just written two different ways. All right? So when you write an and inequality with an x in the middle, you always start with the smaller number and the inequalities point to the left. So when we have an and inequality, you'll notice up here, you start with a smaller number, 2 is smaller than 5, and the arrows will point to the left. Again, here we have two smaller ones. We want to list that first. Because these are written separately, you're not going to have your arrows pointing the same way. When they're written together with your x in the middle, they'll be pointing the same way. All right, so we're going to go ahead and take this and combine it into one single inequality, so it looks like this up here. All right, so I have 3 and negative 10. Which one is smaller, 3 or negative 10?
3.
Negative 10. It's a negative number, right? So this one is what we list first. This one's smaller. I'm going to list negative 10 first. All right. Now notice, so next comes my x. The question is, do I draw my inequality like this, or do I draw like that? So we have to take a look at what we were given. This is where we want to think of it as like an alligator. I can see that the alligator mouth is pointing toward the x. Do you guys agree with that?
Yes.
So when I draw it here, I want to make sure it is still pointing toward the x. So I want to make sure it's still eating that x. Alright. And then we stop to write our 3. So again, take a look. The alligator mouth is pointing toward the 3. It's eating the 3. So we still want it to eat the 3. So just double check, smaller number, bigger number, they're both pointing to the left. Alright. Similar over here. Which one is smaller, negative 4 or 1/2?
Negative 4.
Negative 4. This is small. Alright, negative 4. I'm going to go ahead and write out my number. my x and my other number. See if that makes it easier for us to build these sides. Alright, so for my -4, the alligator is eating the x, so I still want it to eat the x. Over here, my alligator is eating the 1/2. I still want it to eat the 1/2. Okay, so smaller number, the bigger number. This is how we can make sure that what we write makes sense. Wait, how are you going to do all of Wow. This is how we can make sure what we write makes sense. X is in between -10 and 3. So I see this as -10 is less than or equal to x, which is less than 3. That should make sense. Is -10 less than 3? Yes. If we would have flipped it around, then you would have been saying that 3 is less than -10, which is not true. So doing it this way helps ensure that we've written it correctly. So again, our smaller number comes first. We have our x, and we have our bigger number. And all you do is you fill in the signs that they have given to you. They're going to point to the left. So here, my alligator was eating the x instead of the -10, so I want to make sure it's still eating the x instead of the -10. Here, my alligator was eating the 3 instead of the x, so I want to make sure it's still eating the 3. In both cases, your arrows should be pointing to the left. But you just have to make sure you have the correct one. There, any questions with the front side? Which are just solve these. So now go ahead and flip your paper over. And inequalities are my favorite to graph. So our and inequalities are different than our or inequalities. Our or inequalities, remember, they go in opposite directions, right? Or inequalities, they go in opposite directions. They go in opposite directions. And there is an end to it. So the ors, they go on for forever. But the ands, they have endpoints. So x is in between 2 and 5. That means we're just going to shade in between 2 and 5. So I want to go ahead and put my circles on 2 and 5. Is 2 going to be an open or a closed? Closed. So I'm going to put a circle, a closed circle on 2. Is 5 open or closed? Closed. Eric, are you writing this down, my dear? Dan's all going to write this down as well. And x is everything in between. So all we do is just shade in between. That's it. Marjorie, have you written this down? Okay, we don't need a calculator now. We're not solving anything. Alright, so and inequalities, again, it's going in between. So we just have to draw our circles and then connect them. So inequalities are graphed on the inside. X is in between the two numbers. It's in between the two numbers. So again, we have our circles. We draw those first. And is in between, connected in between. Alright, now when we solve an and inequality, it's a little bit more difficult. There's still two separate inequalities, but when they write it all together, then it's like we have two different sides, right? It's like we have the left side, well, three. The left side, the middle, and the right side. So what we have here are two inequalities. Take a look at this. I have 4 is less than x plus 2. And if I cover this up, I have 4 is less than x plus 2. But I also have x plus 2 is less than or equal to 10. Those have been combined together. So when we go to solve, I know that to get x by itself, I have to subtract 2. So now I'm not just subtracting 2 on one side, I have to subtract 2 on both sides because there's two different sides. So when we're solving these, it's helpful to think of there being 3 sides. We have the left, the middle, and the right. When solving, we want x in the middle. Should we write this down? We want x in the middle. And so if we do something to one side, we have to do it to all 3 sides. So before we said, oh, there were only 2 sides of our inequality, right? Before, when we were solving, there are only 2 sides. So when we do to the left, we have to do to the right. But now we have 3 sides. So when we do to the left, we do to the right, and to the left. And then again, we're writing our answer in set builder notation. Alright, so let's take a look at this first one. These really aren't bad. It's kind of, I like them better than the ORs because you can do your answer faster. Alright, my smart board's really off. Let's see how this goes. Okay, so again, I need to get x by itself. What is the opposite of adding 2? Subtracting 2. So I have to subtract 2. But again, I have to do this to all 3 sides. So I'm going to go ahead and draw a line underneath to help me distinguish the 3 sides. So just like we did with the equations, I draw my line underneath. So I need to subtract 2 over here, subtract 2 over here. Let me orient this again for the 3rd time today. Let's see how that goes for us. Alright, I hear a lot of talking that should not be happening. There's a lot of side conversation and that's not acceptable. Please stay focused. If you have questions, raise your hand and ask questions, but we should not be talking and distracting one another. Alan, I don't need this iPad. So now we're going to simplify each thing. 4 minus 2. This be 2. My 2's cancel out here. So I'll have 10 minus 2 is 8. Alright. We have x by itself, so we have our solution. We're going to write this in set builder notation. We subtracted 2.
Oh.
So I'm going to just write this in set builder notation, less than x, less than or equal to 8. And again, when we go to graph this, we're just graphing our circles. And now I have a circle at 2 and 8. Is my circle at 2 open or closed? Open. The circle at 8, is that going to be open or closed? It's going to be closed as well because of the equal to. And then it's just in between. So for our and equations, we get those done a lot faster because we don't have to do a separate one and a separate one. We get to do the same thing to all 3 sides and get to the answer faster. I feel like it's also easier to graph. Alright, so we have questions with that first. Okay, let's do one more together, and I'm going to have you guys try them on your own. Alright, so again, we've got 3 different sides here. So I'm going to get x by itself. So I'm going to have to add 3. I'm going to do that to all 3 sides. If it helps you to go ahead, I've seen some people do this before. It helps you do that so you know that you're about to write a new line. That's perfectly fine. So negative 9 plus 3 is negative 6. Still have my inequality sign. Those cancel. I still have 2x. Still have our inequality sign. 7 plus 3 is 10. Are we done here?
No.
No, we need to get x completely alone. I currently have 2 times x. How do I get rid of that 2? Divide by 2. Again, we have to do it to all 3 sides. Alright, I've been doing all the math. You guys do some math. What is negative 6 divided by 2? Negative 3, good. Okay, so my inequality, my 2's cancel. 10 divided by 2? 5. Half 10 is, or half times 5.
Do we flip this one?
Do we flip? That's a good question. Do we flip the sign here?
No.
Why not?
It is.
Yeah, so we flip the sign when we're dividing or multiplying by negative. Since we're going to use positive 2, then we don't need to flip it. Alright, so again, we have that squiggle, x vertical bar. And then we just list out our answer. -3 less than or equal to x, less than or equal to 5. And again, you can do a quick check to make sure you do this right. We want our smaller number on the left, our bigger number on the right, and our arrow should point to the left. Alright, so I've got a circle at -3, and I've got a circle at -5. My circle at -3, sorry, not -5, positive 5. My circle at -3, is this open or closed? Closed, it's 4 equal to, so it's closed. My circle at 5, is this open or closed? Closed as well, good. And again, x is in between, so I want to go in between as well. Well, it's only the ones where x is in between. So it starts at -3 and ends at 5. So you only want what's between. Yeah, guys, so for when x is in between, we want to have the starting and the stopping point. It's our ors where they go on forever. Okay, questions with this one? So I want you guys to go ahead and try the next one. Try this one on your own. I'll come around to answer questions, help people that need it. If you finish that before we come back to the go over, you can go and try this one as well. There is a fraction that we go and try. And again, I'll come around and answer questions and help those that need help. Just make sure you raise your hand. Any double check attendance too. So you're going to do the exact same thing on all three of them. So if we're doing minus and negative, the same thing. So if we're doing -2 here, then it's going to stay in. So you're calculating -2. Yes. The signs do for both sides. Well, so we have to do divide by -1 to this and to this. Yeah. So what's -3 divided by -1? Are you doing positive? Yeah. There we go. You want to multiply, so you're going to multiply by 2 for this, and for this, and for this. Let's see what happens. Yeah. That's very nicely drawn out. So it's because we're dividing on alternate, we're going to flip both sides. So this literally goes the other way, and that one goes the other way as well. Yeah. Now, negative 3 times subtract -3 minus 2. Negative 5, right? Yeah. And then we have, it's still in negative x, isn't it? The negative is still in x. And then that's, okay, so now I'm multiplying by -1 times it's -1 times x. That's just the x. Well, we're going to have to switch the sign, right? Because we can divide by negative. Yeah. No. Divided, right? No, what's this? What's this sign? We have to switch that sign to the number. Awesome. There we go. So now make sure you write this in the set. Right? You do have to, because it says to create a set. Yeah, when we write it, it doesn't remember what it's a smaller one. Yeah, so everything is here. Now, you want your sign first. Because right now you're saying X by line, right? We want our arrows to point to left. So since we have the alligators giving the X, we want it to use a 5. So you have a crack there. It's down. When you switch it down. Yeah, there is correct. Down here. Raise your hand to get into so I need to have it. Yeah, they just like this. Cool.
You want to say those? Come on, that's rude. That's rude. What did it get compliment?
It's 0. It's correct. Yeah. So the 5 is cancel. All we have left is X. So all we have left is X over 2. So now, go ahead and draw our sign. Remember what yeah. Right, so you want to answer into 2 of them. It's like X completely arranged. Now it's X divided by 2. Relax. So we're going to X divided by 2. It's also divided by 2. Like this one now. Alright guys, let's go ahead and take a look at this one here. I'm going to go to long. Alright, so again we have an and inequality. So we want to draw our lines here. Now I need to get rid of my adding 2 is the opposite of adding 2. Subtracting 2. And I saw a lot of people were doing really well with this. Alright, so I have -5 less than -x. Don't lose your negative. Your negative is still with the x. Less than -3. Now we're not done here. We have to get rid of this negative. So if I have -1 times x, The opposite of -1 times. Divide by -1. Alright. So as you guys found out, it was +5. I have to switch my sign because I divided by negative. And then this cancel. Did you just pick right? Alright, and then I have to switch my sign again because I divide by a negative. And we have a positive. Alright, so you guys did awesome with this. Just remember when you write it in set builder notation, we have to put our smaller number on the left. Which one's smaller, the 3 or the 5? 3. And then I have my x, and I have my 5. Now I have to draw my signs. They should be pointing to the left, but let's just double check. I have my alligators eating the 5. Or my alligators eating the 5. And my alligators eating the x. My alligators eating the x. Okay, so that was the only thing that I saw in some of our papers. You're interested with this.
Is that the wrong?
So this is the correct answer. We want to write where it's the smaller number and the large number and it's pointing to the left. Okay. So that's the.
You didn't flip the signs.
No, I did flip the signs, but when I'm flipping the entire thing. So it's called symmetric property. Take my entire inequality and I'm flipping it around. 3 less than x less than that.
But you're going the same thing.
We're back to the same thing.
These are the same solutions, but this is for incorrect. This one we're not done yet. It's just like if I had 3 was greater than x, we weren't done. We had to flip it around, right? This is what we did before.
Yeah, so the sign.
So you don't even have to flip them.
Okay, guys, listen.
Signs are pointing left, and then
We flipped our signs, right?
divided by 6.
Okay, so we flipped our signs. So now, when we write out our answer, we need to write it so that we read it smaller to larger. Okay, so when we count smaller to bigger. So when we write our answers, we want to go smaller to bigger. When we write our answers, we need to make sure the signs still match up with that. So I am saying the same thing here. I'm saying x is bigger than 3. X is bigger than 3. But because I put the 3 on the left, I have to switch around everything. So it's called symmetric property. We just take the whole thing and flip it around. Okay. So you guys did awesome with graphing this. Open circle at 3. Open circle at 5. Everything in between. Okay. So again, whenever we write out our inequalities, we had that on the front side of our notes. I won't flip it over to it. But we want to write our smaller number first in our answer. Okay, so let's take a look at the other one. So you guys are doing really well with this one too. Okay, so again, I'm going to draw my lines. I need to get rid of my positive 5, so I'm going to subtract 5. I do it on all 3 sides. 0 minus 5 gives me negative 5. Those cancel, so I'm left with x over 2. 5 minus 5, what does that give me?
0.
And it's okay to get 0. We're not going to get it a lot, but sometimes we will get 0. Alright. Now we are dividing by 2. What's the opposite of dividing? Multiply by 2. Alright, 2 times negative 5 is negative 10. Now I'm multiplying by positive 2, so I don't change the signs around at all. Then go up. This is just x, good. What's 0 times 2?
0.
Yeah, it's just 0. Okay, so again, when we go to write out our answer in set builder, the smaller number needs to come first. What's smaller, negative or 0?
Negative.
Negative times is negative. And you can look on your number line too, right? Negative 10. So it's in the proper order we want it. Alright, so when we graph this, close circle at negative 10, and an open circle at 0, everything in between. So let me go and zoom out so you guys can see that entirely there.
Every single time does it have to be?
When it's the and. So remember the difference? Our and, it's all written together. Our or, it literally says the word or. That's when it goes in opposite directions. So So Anthony asked a good question. Is it always going to be in between? When we have and, it should be in between, right? X is in between 2 and 8. It starts at 2, stops at 8. But when we have or, it's everything underneath negative 2 and everything bigger than 2. Okay, so now the bottom part of our notes there. Remember, an and inequality has 2 inequality signs, right? So we see this inequality, and we see this inequality here. So again, when you have, so this would be an and, right? There's 2 inequality signs. This is an and. There's only 1 inequality sign. It's not an and or, it's just a normal one. It's just 1 inequality. Here we have 2 inequalities. An or has 2 inequalities. This is just a normal inequality. Okay, let me go and hand out your homework to you. You go ahead and start returning your calculators.
I was thinking a little bit. Guys, your homework is coming back to you. Your homework is worksheet 10. Make sure you grab that before you go. Already got it. Worksheet 10. Keep in mind that if you want to grab a paper to request to check out a calculator sitting over on the bookshelf, you can grab one now or as you head out. Is there anyone that did not get the homework? Guys, make sure you pass back the homework. Pass back the homework. Okay, thank you. Here's a couple. And remember, you're going to TA. You're going to TA. What's the stinger? Stinger 3. TA, stinger 3. Sorry, Eric, I forgot why you were waiting on me. Say out your phone first. Bye. Have a good day, guys. TA, stinger 3.